Hi, my name is Peter Vegh, and I'm Senior Consultant at OpenCredo. Recently, I've been building and playing around with my Kubernetes cluster, this guy, and I found Kubernetes networking one of the most difficult things to grasp. So I decided to put together this short talk where we're going to try to track down together how does it work. So we'll be starting from here, which is pretty much reflects my initial knowledge about networking in Kubernetes. And we will try to get rid of all the red spaghetti and question marks that I put up there. So from here, we'll be exploring together the various components of the Kubernetes networking. And by the end, we'll see how my containers across these two pods are running on the same host and how can they communicate to each other. Let's go through quickly on my deployed example applications. To do that, I will just list the pods in my cluster first using kubectl. Right. As you can see, I've got two pods. One of them is called web server, which is running two containers, and then there's web server 2, which is only running one container. So let's list all the containers of each of these pods. As you can see, web server has two containers, Nginx and Sidecar. It's called Sidecar because they're actually running in a Sidecar fashion, but it's a busybox instance. And then web server 2 is just running an Nginx instance. The actual setup of this test case is not super exciting, actually. I just wanted to see like how IP addresses are assigned when you have multiple containers in a pod. So the first thing that we're going to want to see how IP addresses are assigned to my containers and what is their relation to the pod IP address. Unfortunately, I can't execute commands against my containers as they are quite restricted. So what we will need to do is log into the node where my pods are actually running, find the process ID for the pod, and then the process's names. And then we're going to need to enter into the process's namespace. And once we got there, we can actually run any command that we want. That is available on the host machine. So what we're going to do, we're going to run IP address commands against those containers and then check what's the IP address assigned. So I've logged into the pod where my pods are deployed. My chosen container runtime is containerd. So let's list all the running containers on this node by calling ctr, which is containerd CLI. You can see the containers for my pods, the two Nginx instances, and the busybox. You can also see quite a few post containers. If we count them, and we can see that there is one for each pod. Knowing that, let's try to identify which post container lives in my web server pod. We can do this by actually looking at the container information labels, running CTR again. So, what are these post containers? In Kubernetes, the post container serves as a kind of a parent container for all the containers inside your pod. Kubernetes creates post containers to acquire the respective pod's IP address and set up the network namespace for all the other containers that join that pod. It has some other responsibilities as well, but we're not going to discuss those. Right, so that was a little bit of derail. We are still on the mission to figure out what are the IP addresses of my containers. And also because we know that there is actually 3 containers lives in our pod, the post container, in our web server pod, the post container, the Nginx instance, and the busybox instance. We will look at all 3 of those IP addresses. So to actually do this, we will need to acquire the process ID for each of these containers, which we can do by running runc. I'm just going to show you one, and then the rest I will just do for the next step. So this is the runc output after a simple listing containers for my post container ID. As you can see, this is going to be the process ID. And what we're going to do now is we're going to enter into the process namespace and then run the IP command against the container. So we'll see what are the Ethernet interfaces on this container. I will also do the for the other two containers, but I'm not going to go and grep for all the container IDs now because I know them already. So I'm just going to get the IP address assigns with the nsenter command. As you can see, every container has the same IP address as they are sharing the same Ethernet network interface. If we look at the IP address output carefully, we can also see that these are virtual Ethernet interfaces. So why is it important? It's going to be important. So what are these Ethernet interfaces, virtual Ethernet interfaces? So virtual Ethernet interface is a local Ethernet tunnel, and they are always created in pairs. In our case, one end is going to be this Ethernet 0 interface, which sits on the pod in the container's network namespace, and the other one is going to be on the host machine in the root namespace. So let's have a look at all the interfaces that are actually running on our host machine, and let's try to pair the Ethernet interface inside the pod to the one that's actually running inside the host machine. To do this, we just need to have a look at the after the little device ID inside the Ethernet interface name, and that will tell us that which virtual Ethernet device it is actually linked to. So let's just run the IP command again, this time on the host machine. You can see there are quite a few devices. The device that our Ethernet interface inside the pod was linked to was device ID number 26, which is this. As you can see, this is a virtual Ethernet device. And then you can also see that it's a bridge slave, which is quite important. Let's just quickly have a look at the other virtual Ethernet interfaces because we have 4 of them in my case. So each of them is a bridge slave, and they will be all connected to the only bridge that I have, CNI0. So what are Linux bridges? Linux bridges behave like a network switch, and what they can do, they can forward packets between interfaces that are connected to it. So in our case, they will be able to forward packets between these virtual Ethernet interfaces. And pretty much that's it. So to summarize it up, we started somewhere here, knowing pretty much nothing about networking in Kubernetes. Then we got rid of all the red spaghetti and question marks, and I identified each of the components that are responsible for networking in Kubernetes. Let's take a look at these. So indeed, we identified a post container, which is managed by Kubernetes, and it's responsible for bootstrapping the network namespace for each of our pods. We also saw that every container inside a pod shares the same virtual network interface, which is called ED0 in our case. Each of these virtual Ethernet network interfaces are connected to a virtual Ethernet device. So a package will travel from the pod's network namespace to the root namespace, from which it will be picked up by a bridge. The bridge will route the package to the destination virtual namespace, virtual Ethernet interface, and then it will go down to the pod2's network namespace, just like that. This pretty much concludes what I wanted to show you during this talk. Obviously, networking Kubernetes is a lot bigger, so there are still quite a few components that we haven't touched. For example, services, ingress, load balancing. If you want to hear about them, then leave a comment in the section below. Also, if you like this talk, or you found it useful, or you have other comments or criticism, just leave it in the comment section below. Thank you.